Welcome back. So we are entering now in a new set of chapters which broadly according to the Indian boards they are taught in class 12, and I have the privilege of introducing to you what is an electric charge. An electric charge, which studies of which lead us initially towards known as electrostatics, wherein we learn about forces, fields and potentials from static charges. Okay. Forces we know, fields we know, and potentials maybe I'll elaborate when the time comes. But we know about potential energy. Okay. In the last set of 105 lectures outings that we had, the main thing that we got out of it is the set of laws known as Newton's law of motion and Newton's law of gravitation. Plus. Okay. Now, that led us to understand about the long range forces which we call the gravitational force, one of the pillars of the mechanics and the functioning of the universe. Okay, that's the weakest of. There are four forces. We are not going to talk about the short range forces, but the long range forces, I told you there are two types. One is the gravitational one, which is very weak as compared to what is everything that happens around us is due to electromagnetic forces. Well, electric and magnetic forces were combined in the due course of history, but let's go back to what is recorded history and what we teach people, that around 600 BC, 260 years before, 2600 years before, Greece was a hub of knowledge. Lots of saints and teachers and others, thinkers, philosophers, they came up in Greece. And there were the Thales of Miletus, who talked about electron, meaning amber. Amber, which is a kind of a resin, the electron, and it is obtained from the trees. It is normally used in jewelry, and the color is varying from yellow, around yellow. Beautiful beads are made and etc. etc. And he found that the amber and many other things, when they were rubbed by cat's fur or by silk, etc., then they had very interesting properties associated with them, that of attraction and that of repulsion. Okay. Now, because of rubbing of one material with another material, something is removed from one material to another material, and one material becomes rich in something and the other loses something, and the loss and the gain both are beneficial to the people living on the earth otherwise. Okay. Now, they found that there is an element of love and an element of hate. Love means attraction. Come on. How are you? Ahlan, sahlan. Okay, like that. Attraction and hate. Barra. Keep away. Go go farther from me. That kind of a hate relationship existed, and they found that the unlike things, okay, they attract, and that is when unlike means plus and minus and minus and plus. I will come back to Benjamin Franklin, who said that they can be categorized among plus and minus. And then we had the repulsion. Plus and minus don't like each other. Okay. How much they like, how much they don't like, it all depends upon many things, particularly the closeness and nearness, etc. between two things. My. There was a Belgian scientist in the Americas. His name was Benjamin Franklin. Americas were discovered by new set of people in the 16th century. And the old Red Indians and other population, Aboriginal population, they are now reduced to naught. I mean, yes, their number has fallen. Anyway, so many people, they rush to the Americas for prospecting purposes, and there were many kind of people. So this man, Benjamin Franklin, he, between these years, naturally, in the middle of the 18th century, he decided, he studied, and he said that the charges are positive and negative. He categorized them into positive and negative. Anything positive is more than zero, and anything negative is less than zero. And in between there is zero is equal to zero. Oh, so this is I am introducing. Okay. Well, how come these charges obtained by rubbing one kind of rod, another kind of rod, this, that, this, many things are there which I leave for you to study all by yourself. That's important, that should not be missed. Then the story comes about a gold leaf electroscope. When we touch that instrument with the help of the charge body, then naturally that charge flows, and there are two leaves made of gold which just separate. The extent they separate gives us an idea of how much charge has flown into that, etc. This for you again to understand. Basically there is a repulsion, and if that charge is taken off by some means, then the leaves, they collapse, they come together, okay, else the leaves, they will go like this. Okay, no problem, you can take up that, read that through any text, and you must have been introduced and is introduced in the high school classes, etc. Now let's examine the matter around. When we examine the matter around, solids, liquids, gases, this, that, okay, then we find there are two distinct properties which are there. Some of the materials are conductors and some of the materials are insulators. I'll just tell you about the human body is a conductor, but I'll tell you about water. If the water is very pure, that means maybe the allowed impurity content is 1 part in 10 to the power of 12 or 1 part in 10 to the power of 14. There are only H2O and D2O molecules which are there, hydrogen oxide and deuterium oxide, which is one of the isotopes, you know. Then that water is a bad conductor or an insulator. But if there are any impurities in that, then that water becomes conductor. Normally, metals, alloys, etc. are conductors. Wood, plastic, etc. Plastic is a very new product. So wood, etc., cork, etc., they are insulators. What it means, conductors? Conductors means some kind of charges are flowing through them easily. And those same charges will not flow through the insulators and will flow with a lot of difficulty. So they offer little resistance to the flow of these charges, and whereas insulators offer almost very big resistance, okay, to their flow. And in between these two categories of materials are some group 4 materials like silicon, germanium, etc. Some 3,5 materials, 2,6 materials, group 2,6 materials, which are compounds, some organics, etc., which come in between. Their conductivity is between those of conductors and insulators, and they are called semiconductors. Okay. Now, from time immemorial, we knew that the matter could be broken, could be broken, could be broken, could be broken. Ultimately, what is said that all the chemical properties are in the molecules. This is the minimum size of the matter which defines the chemical properties. Anu, and this is Parmanu, atom. Atom means not divisible. Okay, so atoms were, but they were divisible. We learned in the due course of time that the atoms comprise of any element a nucleus. A nucleus which houses its protons, which are positively charged, and neutrons, which are negative. They are not negatively charged, they are neutral. Okay. And this is the nucleus. And there is a cloud of electrons which is orbiting around the nucleus. The radius of the nucleus is of the order of 10 to the power of minus 15 meters, whereas the radius of the atom in general is of the order of 10 to the power of minus 10 meters. That is Armstrong degree. Okay, Armstrong. So, it is, almost from the 20th century, between 1890 and 1935, we learned about the constituents of an atom. First of all, what we got is, this is number one, it was determined that there are electrons. Their masses and charges, etc. I'll tell you what is charge. Then the protons were discovered as the number 2. And the last, the neutrons were discovered probably in 1932, and as soon as Chadwick, he discovered the neutrons, he was awarded the Nobel Prize. Because Nobel Prizes are given mostly for achievements which were not there, okay, which changed the course of physics, which changed the course of humanity. Okay, they were started around 1900. Anyway, now we also found that the mass of the proton is very, very large as compared to the mass of the electron, about 1870 times. Mass of the neutron is approximately equal to the mass of the proton, and that mass of the neutron is very, very large as compared to m. I will not go in more details. Okay. Now, as I told you, that the nucleus even nucleus is sort of empty. Okay. In nucleus, however, the electric and the gravitational forces are not of importance, but there are two other forces which we call fundamental forces, the strong nuclear force and the weak nuclear force. We'll have, I talked to you about before, but we'll have occasion to talk to you about that when I'm dealing in nuclear physics. Now, that means most of the matter has empty space, which we have to explain, which we have to understand. Empty space means that there is no matter over there. That is vacuum. Okay. Now, for the conduction purposes, we'll talk about what are free electrons, which are plenty in the case of metals. Because in metals, some of the electrons are attached to the metals with such attractive energy that this energy can be supplied when we are rubbing it, etc., and they detach, but they don't get destroyed. Similarly, we have in the case of, for example, sodium chloride. If I put it in water, sodium and chlorine atoms, they become ions. Okay, sodium becomes positive, chlorine becomes negative, etc. And they are in that water environment. So if I have two plates, I make the potential of one higher as compared to the potential of the other. One is positive, the other is negative, then these ions, they start moving. So this is ionic conduction which takes place. Okay. Once something like a rod, etc., is charged and we touch one matter by another matter, then one body by another body, then the charge gets transferred from one body to another body and is distributed. We'll learn about how they are distributed, etc., etc. Okay. Then there is charging by induction. I hope that you read about these things all by yourself. Well, I will tell you that our earth, Mother Earth, okay, or Father Earth, is a a huge reservoir of electric charge. So electric charges, if they are in excess, they can discharge to the earth, and the earth comes to our help. Okay, and therefore we have a mechanism of earthing. Even in the wiring system we have earthing for safety of appliances, etc. And basically, before 600 BC, before the tales of Miletus, there were two things. Okay, Bijli. What time? When the clouds, they brush with each other. Okay, when the clouds, when they rub with each other, then a kind of a discharge happens, and there is what we say that there is bark or there is bijli, which is falling to the earth. Okay. That bark or bijli is the lightning. Okay, that is related to clouds, and that is related to the rainy days, particularly in the tropical countries like ours in India. So after this discussion, we are going to talk about the basic properties of charge. Charge itself is a basic property associated with a particle. A particle, as we know, has got two facets to it. One facet is called its mass, and the other is called its charge. Electrically neutral particles have no charge on them, but those which are not neutral, they may have positive or negative charge. So there are three salient features of the basic properties of electric charge. I'm just going to tell you in the passing, because in the next lecture, before I go to Coulomb's law, I will elaborate on these again because it helps. Normally a charge is shown by a small q. In most of the languages, the Europeans, and we have also adopted the same in India, Pakistan, Bangladesh and the Orient, Sri Lanka, Nepal, Thailand, etc. We are following that pattern. The Q is taken as a symbol of charge. So additivity of charges. If you have an ensemble and if you bring in particles, many particles, number 1, number 2, number n minus 1, number n, okay, n may be a very large number, it doesn't matter, then the total charge, it is simply the algebraic sum of all these individual charges. They have just shown as summation I is equal to 1 to n qi, okay, where this is an individual charge. The second item that we must take into consideration is the conservation of charges. Okay, interesting thing that the charge is conserved. It can neither be created and nor be destroyed. In Arabic we call it ma khalaq, no creation, and ma fana, no destruction is possible. So whatever charges have been created, they have been created, they can be added together by the additivity of charges, so the charges are conserved. Well, there was an occasion when I told you that m, the mass, okay, this can be converted, okay, this can be converted if the mass is equal to m naught and we multiply by c square. The famous Einsteinian equation is that the energy associated with it is like this. There is no such relation for charges. Also, we said that m is equal to m naught into something, which shows that at high velocities the mass, okay, is different from the mass at low velocities. Okay, this is just, I am not giving you the things so that you are able to search for it, and when you search, then you remember. Okay, so conservation of charges. In electromagnetism, which you are studying, the charges are conserved, they don't change. Okay. For the whole Brahmand, the total charges are conserved. Of course, if the whole Brahmand, the cosmos, is built up of atoms, and all atoms are electrically neutral, so the whole Brahmand in toto will be electrically neutral by the atomic theory of matter. Then there is quantization of charges. The charges are quantized. That is, if I take a basic charge, which is, I am just giving you the value as 1.6 into 10 to the power of minus 19 coulomb, which is the charge on the electron, okay, and also on the proton. Okay, it can be negative, it can be positive, it doesn't matter. Okay. Then, if we have a charge, okay, and if I divide it by this value 1.6, the charge value divided by 1.6 into 10 to the power of minus 19 coulomb, we will always get an integer, okay, which is 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, etc., etc. Okay. So when we explain to you the additivity of charges, the conservation of charges, and the quantization of charges in bit detail, then we take all these things with us, with all these tools in our possession, we go and study Coulomb's law with Mr. Coulomb, which we'll do in the next lecture. So wait for that, we go for Coulomb's law in the next lecture. Thank you.